Okay, good morning, class. Okay, so as usual, let's recap on what we have learned yesterday in the previous class. Okay, so yesterday we learned about gas laws. Okay, and there are 4 gas laws. Okay, we have A, B, C, and D law. Okay, so let's recap quickly on each of these laws. So the first law is, okay, very good, thank you. Avogadro's law. So Avogadro says that volume directly proportional to number of mole. Okay, so what is kept constant? Pressure and temperature. Okay, thank you so much, gentlemen. I hope to hear more voices. Okay, second law. All right, very good. Boyle's law. Okay, so Boyle's law talks about pressure and volume, directly or inversely? Inversely, okay? Inversely means if one of it increase, another is going to decrease. Okay, so what is kept constant? Temperature and number of mole. Okay, we have 4 factors. So if you are testing 2, the other 2 will be constant. Okay, all right, what is C law? All right, Charles' law. So Charles' law talks about volume directly proportional to temperature. So what is kept constant? Pressure and number of mole. Okay, and what is D law? Okay, so what are the 2 assumptions that you have to remember in Dalton's law? Okay, no interaction, okay, between the gas particles. They will not have any interaction. And next one, own pressure. Okay, they will give their own pressure independently. Okay, that means the gas will not care about the other gases. Even if I mix them together, they will still exert, okay, give their own pressure. Okay, very, very good. Okay, next, kinetic molecular theory of gases. Okay, let me just move it here because this one also a lot of points. Okay, kinetic molecular theory of gases. We talk about the movement, the kinetic of the molecules of gases. Okay, there are 4 things. Okay, so this kinetic molecular theory, it says that if let's say my gases are ideal, my gases are perfect, how should they behave? Okay, so there are 4 behaviors of perfect gases, 4 indicators that my gases are ideal gases. Okay, what are the 4? What is that?
Don't matter that much.
Okay, the size, okay, the size of the atoms does not matter. Okay, or another word you can say that size is very small and the volume is very large. Okay, remember I gave you an example. So the volume is so large and then the size of the particle is so small. So we say that the size does not matter. The size is negligible. The size can be ignored. Okay, all right, second one. Okay, elastic collision. If there are collisions, the collisions are elastic. Elastic means like a rubber ball. I throw it on the wall, it bounces back. Okay, so elastic collision. 3, what about the movement? Random, okay, constantly moving, keep on moving, and in a random direction. Constant random motion. Okay, are there any forces of attraction? No, okay, so also negligible, or you can say there is no force of attraction. Sorry, I'm going to use FOA, force of attraction. Okay, so ideal gases will behave this way. Okay, but of course we know in reality, this is our expectation. Okay, but in reality, of course, they don't behave 100% this way. Okay, that means sometimes the volume will matter. Sometimes there will be a little bit of forces of attraction. Sometimes, okay, the collision collide already, not necessarily 100% bounce back, but maybe bounce back 89%. Okay, so this is kinetic molecular theory. Okay, and then we talked about ideal gas, which is our perfect gas, and also real gas. Okay, so there are 2 conditions where my ideal gas becomes real gas. Okay, do you remember?
Yeah.
Okay, pressure is high because when pressure is high, volume is low. So when volume is low, volume so small and my size of the particle is the same. So the size of the particle has to matter. Okay, it will be significant. Okay, those explanation, you can look for it in the slide. And the next one is temperature is low. Okay, because when temperature is low, I have energy which is low, not enough for me to constantly move, not enough for me to break the forces of attraction. Okay, okay, and then the other way around, how does real gas behave more like the gases that I mentioned in the kinetic molecular theory?
Lower.
Okay, so the opposite, right? Okay, so yes, okay, because when pressure is low, volume is high, Boyle's law. Okay, so when volume is high, size of the particle does not matter. Okay, and then when temperature is high, I will have a lot of energy. So those a lot of energy, enough to break any forces of attraction temporarily. Okay, just like I tell my students, okay, let's say you're walking to the cafe, okay, very quickly in a rush, okay, you have a class in 5 minutes, but you were very hungry, so you went to the cafe. And then on the way to the cafe, okay, you met a very pretty girl, okay, and then the girl wanted to say, okay, can I have your number? Can we keep in touch? Okay, and then you're like, I'm so busy. Okay, the bond is about to happen. Okay, it's about to be created, but you were so busy, you were moving so fast. No, like 5 minutes, and then you rush off. So the bond is broken. Okay. All right. So this one is our recap for today. Anything you want to clarify? No. Okay. Because I see your mood is like going down. Okay. So I talk about something else last. All right. So today we are going to start with a new chapter, chapter 2. Okay. So chapter 2 is atomic structure. So just now in chapter 1, we talk about atoms, we talk about molecules, we talk about particles, okay? So chapter 2, we will zoom in the atom and look at what is in the atom. That's why we call it atomic structure, the structure of the atom. Okay. All right, to those of you who have to get the notes from, anyone got the notes from Moodle already? Okay, I'll give you guys around 1 minute. Okay, try to get it. For your information, when you want to get the notes from Moodle, you have to answer a short quiz. Okay, it's called Test Yourself. So test yourself, you have questions about chapter 1. Okay, so you can just answer. For example, this one, okay? Before this, to unlock, you have to get everything correct in Test Yourself. So you go to Test Yourself, you attempt the quiz. Okay, hopefully for subsequent chapters, okay, you will be responsible. You know, we have finished chapter 1. We will go into chapter 2 today. So get your notes ready. Okay, so you can answer the questions. Okay, for example, all the questions are from chapter 1. So you can choose and you can even check. Okay, let's say you got it wrong. You can check. And then you know that this is wrong. Okay, then you can correct it and check again until everything is correct. Okay, then you go to the next question. All right, that's how you unlock your next chapter's slide. All right, everyone, okay, can you start the class? Okay, hope you have your slides ready. So today we are going to move on to the second chapter, atomic structure. Okay, so as usual, learning outcome, we will leave at the end of the lecture. Okay, so why is it important for us to understand the structures of atoms? Okay, atoms are already small enough. Why is it not enough for us to just study about atoms? Okay, because for example, sodium metal. Okay, what is the characteristic of sodium metal? Anyone did an experiment with sodium metal last time in secondary school before coming to foundation, whereby you put a sodium metal in the water? Yeah, it's going to jump and explode. Okay, so it's very interesting experiment, but it shows that sodium metal is very, very, very reactive. Okay, and then I have chlorine gas. Chlorine gas is actually very toxic. Okay, if I leave you in a room with a chlorine gas, okay, you're going to suffocate and you're going to be intoxicated. Okay, so two very reactive materials when they are individual, but when I combine them, it becomes something that we can eat. But we cannot eat only sodium metal. We cannot eat only chlorine gas, cannot. But when we combine them together, they become something that is edible. Okay, that is why we have to learn the atomic structure. The atom itself is not enough. We look into the structure inside the atom, why they can cause a reaction. Which one can react with which one? Then only we will know how do we produce something not dangerous from two things that are very dangerous. Okay, so atomic theory, okay, this first theory is from John Dalton, okay, says that particles, okay, all matters are made up of atoms. Everything, just like biology, you say everything is made up of cell. But in chemistry, everything, okay, even smaller than cell, we have atoms, okay. 9-12. Okay, so those who are late, okay, please give me your name later. Okay, so these atoms cannot be created, cannot be destroyed. Okay, you cannot create an atom out of thin air, you cannot destroy the atom. Anyone watch Oppenheimer? Okay, you know Oppenheimer, they try to create a new atom, okay, by putting in protons, but cannot. Very, very, very difficult. Okay, so it's extremely difficult, cannot be created, cannot be destroyed. Okay, so remember in the first class I showed you, okay, the atoms, if they are from the same element. For example, if I have sodium, atom, they are identical. Okay, atoms of the same element, they are identical in size. Okay, and then how do I form compounds? Compounds are formed when I have different atoms, different elements come together, atom and atom, then I form a compound. So this compound can either be covalent or it can be ionic. Okay, so atomic theory, what is atomic theory? Atoms cannot be created or destroyed. If I have the atoms from the same element, they will be identical. And then compounds, if I want to form a compound, I have atom and atom mixed together, I form a compound. It's just a matter whether it's a covalent or ionic compound. Okay, so this one, okay, I think I've shown you during the first class as well. So you have a pencil, you can see the pencil. If you zoom in, I've shown you how a carbon atom looks like, very, very small. You zoom in, you'll be able to see the carbon atom. And from the carbon atom, one carbon atom, you zoom in further, you have something, okay, this is atom. When you zoom in further, you have something called subatom particles. Okay, that means the particles inside the atom. Okay, so what are the particles inside an atom? You will have neutron, things that you are actually familiar with, neutron, electron, and protons. Okay, so proton and neutron will make up the nucleus, and the electrons will be moving outside the nucleus. That is why only electrons can be thrown off, okay, from an atom, can be removed. Proton and neutron cannot be removed, okay? So a proton especially cannot be removed, okay? Then electron can. For reaction, I'm going to donate or receive electrons. Okay, so this one just a recap, okay? Atom means single. One atom, two atom, three atom. If I have one atom plus one atom, it becomes molecule. Okay, just like wording, words. Okay, alphabet, each of these alphabet, they are the atom. If I combine the alphabet, they become one word, then the word is a molecule. Okay, so molecule is combination of atoms. For example, I have chlorine. Cl2 is made up of two atoms. Carbon dioxide is made up of one carbon atom and two oxygen atoms. Okay, let's play a simple exercise, okay? since you guys are also okay, so here again, okay, you can scan the QR code. Again, the same instruction. Okay, put in your student ID. Don't put in your name. Put in your student ID, FIS2308, blah, blah, blah. Okay, so you will mix and match the characteristic. Electron, what is the characteristic? Proton, what is the mass? Okay, what is the function? What is the characteristic? What is the charge? Okay, and neutron, what is the characteristic? Okay, give you guys 1 minute, then we will discuss through the answers. Remember to put in your student ID. That's how I track your participation in class. Okay. Do QR code again. Okay. Drag and drop. Okay, what are the characteristics of proton, neutrons, electrons? Still no students have finished the exercise yet. Very difficult.
No, I just.
Oh, cannot fill up your name? Anthony. Hold on. Okay, try this. Does it ask you to fill up your name?
Yes.
Ah, yes, right, the new one. Okay, this is the new one. Okay, must tell me lah. Okay, got something like this, you have to tell me. Okay, cannot fill up your name or what's wrong. Okay, you let me know. Now you were prompted to fill up your name, right? No, maybe if I Okay, yeah, there are some results. Okay, very good. All right, let me know. Okay, let me know if there's any mistakes there. Okay, so you let me know, then I can rectify early. Okay, I was waiting and then so nervous. Okay, no one has finished yet. Okay, 547. 547. Proudly raise up your hand now. There's nothing to be embarrassed about. Okay, what's your name? Huh? Huh? Soher. Okay, so all of you Soher. Okay, it's you. Okay, 542. Okay, Jeremy. 798. Oh, what's your name? Huh? Baliana. Oh, Baliana. Which one is it? Sorry, I want to get your name. FIS2 or 1? 2. Which one? Five, 7, 9, 8. Oh, sort both. Oh, how do you pronounce it? Oh, Valerie. Oh, but sort both. Oh, Valeria. Oh, sorry, I cannot pronounce it. Sort both. Can I call you sort both? Okay, I'll get back to you later. Okay. All right. Thank you, class, for participating. Okay, let's discuss the answers. All right. So here, okay, I'm just actually putting it in the form of a game so that you can mix and match. Again, okay, it's about the slides, okay. So properties of proton, the charge of proton. Proton shows a positive charge and it's one charge, okay. One proton is positive, one charge. Okay, the mass of proton, okay, there is a mass, okay, so we consider it as heavy. Okay, so one proton will give roughly around the mass of 1. Okay, so we consider it as heavy. Location of proton is in the nucleus. And the function of proton, what is the function of proton? The identity, okay? Remember I did mention before, the same proton number must be the same element, is the identity number. Okay, so determines the identity. Okay, electron is the opposite of proton. So there's a charge of -1. Okay, and electrons are very light. Very, very light. That's why electrons can move. Okay, so virtually zero, virtually no mass. Location of electron, okay, it's outside of nucleus. It's the only thing that I mentioned just now, outside of nucleus, so it can move in and out of the nucleus. And the importance of electron, it is responsible for the activity. Okay, electrons, the valence electron is the one that determines whether what is the reaction that's going to happen. Okay, is it covalent or is it ionic? Okay, and lastly, neutron. Okay, neutron does not have a charge, is 0. Okay, but then there is a significant mass of neutrons, so we consider it heavy. That's why you see, okay, if you remember, nucleon number, okay, is the number of proton plus number of neutron. Okay, let's say you have 9 proton and 10 neutrons, you will have the mass number, okay, equals to 19. So each of the proton consider as like heavy 1, and each of the neutron also consider 1 heavy. The mass is significant. Location of neutron, okay, is in the nucleus. And the function of neutron, okay, holds together nucleus. Can somebody try to explain to me why do you think neutron can hold together the nucleus? Why is it this function? 0 charge, okay, very good. And then?
Because the constant
Okay, yes, okay. Proton, if let's say my nucleus, in this circle of nucleus, I have protons. We know that same charge, proton and proton, same charge, what do? Repel. Okay, repel each other. So if let's say there's only protons in the nucleus, they are going to repel. Okay, so that is why we have to put in something which is neutral charge. Okay, so the neutron can get in between the proton and prevent so much of repulsion. So it can hold together in the nucleus. Okay, all right. So if let's say I have an electric field and then I put in protons, positive charge, and electrons, negatively charged. Okay, we know that opposite charge attract. Just now you mentioned same charge, they are going to repel. So opposite charge, they attract. Okay, so let's say here is my source. I have electrons negatively charged. Negatively charged will be bent to positive terminal. And likewise, positively charged proton will bend to negative terminal. Okay, can somebody try to explain to me about the bond angle? Why the angle of electron is like this and the proton is like that? Inertia, okay, what else? The mass, okay, explain. Further. Okay, proton, it's heavy. Oh, yes, okay, electron is light. Okay, something that is light, is it easy to be pushed or hard to be pushed? Easy. Okay, when you're very light, okay, the wind blow, then you fall down. Okay, so easy to be bent. That is why electrons will be bent more. Okay, so you see the bond of electron, alpha, the bond angle is larger. Okay, the angle of deflection, okay, is larger than beta. Beta is the angle of deflection for proton. Okay, because proton is heavier, so deflected less. Electrons are lighter, deflected more. Okay, so here electrons are lighter, so they are deflected more. Okay, so question. This shows the possible path of subatomic particles. Remember, subatomic, that means the particles inside the atom. Okay, which diagrams are correct? Okay, how many of you chose A? B? C? Okay, very quick, okay? Negative charge go towards positive, correct? Neutrons, no charge, move directly. Yes, correct. Proton should be going where? Negative. Okay, so it's 1 and 2. Okay, next. Okay, also a refresh. Okay, we have mapped this in the first class. So let's say I want to write the symbol of my element. Okay, handphone down. We don't need to do activity. We don't need handphones. Okay, so let's say I want to write the symbol of an element. Okay, so this is my element. Okay, I put the symbol. And this represents mass number. Again, what is mass number? Another name? Nucleon number. Okay, and what is nucleon number? Proton plus neutron. Okay, and then what is atomic number?
Number of protons.
Okay, very good. Number of proton. Okay, all right. So if I want number of neutron, I use the nucleon A minus the proton set. Okay, so proton number is what makes an atom what it is. It means that proton number is the one that determines the identity of the element. So, for example, if I have proton number 11, I must be sodium, cannot be anything else. It's the identity. Okay, in neutral, if I have a neutral atom, so electron is same as proton. That's why they are neutral, because negative same as positive, so they are neutral. For example, oxygen. Okay, mass number 16, atomic number 8. So I will have number of proton 8. It is neutral, so number of electron also 8. And number of neutron is nucleon minus proton, so I will get 8. 16 minus 8. Okay, if I have negative ion. Negative ion is anion, negative. Okay, if I have anion, because it is negatively charged, that means I have more electron compared to proton. Okay, for example, the same element oxygen. Notice here, proton number remains the same, cannot change, because I am oxygen. Oxygen always proton number 8. Okay, number of electrons. Because originally in neutral, my electron is 8, same as proton. But now I have a 2 minus charge, so I plus 2 electron. I'm adding in 2 electrons, so I will have a total of 10 electrons. Okay, meanwhile, number of neutron as usual, I will have nucleon number minus proton number, so I'll have 8. Okay, positive ion, cation, okay, positive. Okay, when I have electron less than proton, the only thing that's going to move around is the electron. Whether I have extra electron or I have less electron, proton will remain the same. Okay, for example, sodium, proton number remains because this is the identity, always 11. Number of electron, okay, originally in neutral, I will have 11 electron, but now I have a positive 1 charge. What does positive 1 mean? Remove 1 electron. So 1 electron is removed, I minus 1. So I get electron 10. Okay, and number of neutron, we have nucleon minus my proton. So I will have 12. Okay, which isotope of an element in the third period of the periodic table will have the same number of neutron as this element? Okay, give you some time, try to calculate this and tell me what you get. Okay, among A, B, C, D, which one will have the same number of neutron as sulfur 32? Okay, how many choose A? B, C, D. Oh, okay. All right, so how many neutrons are there? 16. Okay, so this one, A, how many neutrons? 12, 12, 14, 16. Okay, all right. Moving on next, can you try to complete this for neutral atom? Okay, give you guys around 1 minute while I have a spot check around. Oh, you have the answers? Okay, just quickly run through. Neutral. Okay, if it is neutral, that means which one is the same? Proton and electrons are the same. So this one you'll have 23, 38, 15. Okay, how do you calculate neutron? Neutron minus proton. Okay, so very quickly, you'll get this as 28, 50, 16. Okay, can finish within 1 minute. Okay, all right. Okay, deduce the number of electrons in each of these ions. Okay, again, try this. All done. Okay, hold on. Okay, so number of electrons. Before you determine number of electron, you must first write down what is the number of proton. Okay, so this one proton, 19. And then what happened? -1, remove 1 electron. Okay, so you will get electron 18. Very good. Okay, this one, number of proton, 7 plus 3, because it's -3. I take in 3, 10. Very good. Okay, so this one, proton, 8 plus 2, because 2 charge, also 10. Okay, and this one, 31. Okay, yes, -3, 28. Okay. Seems very simple when we do this, okay? It's like very low standard, okay? But when I ask you to do this in exam or quizzes, then suddenly some of you, I don't know what happened to your brain, okay? Got haywire, cannot answer. Okay, so that's why we need a bit of practice like this. Okay, try this. Hot water contains calcium ions and hydrogen carbonate ions. So this is the formula, calcium hydrogen carbonate. How many electrons are there in hydrogen carbonate, anion? Anion, huh? Okay, try this, challenge you. Okay, anyone who has gotten answer, maybe you can raise up your hand, and I can see how many of you have gotten, then I can start with the discussion. Okay, Samad. Okay, yes, Samad, put down your pen. I see nothing. Okay, who else? No, haven't? Huh? Okay, try. Sunny. What's your name? Huh? Chao. Oh, what's your name? Oh, okay, anyone else who have gotten the answer? Okay, a few. Okay. Okay, giving you a heads up, okay, how to start. I have calcium ion. What is the formula for calcium ion? Ca, 2 positive, okay. Again, refresh, 2 positive because it's in group 2. Okay, so 2 valence electron, 2 positive. Okay, hydrogen carbonate. Okay, if you have no idea, I give you the formula here. Okay, so CaHCO3 2, correct? So this CaHCO3 2 is made up of, okay, we have calcium and we have hydrogen carbonate. Okay, you can actually get the idea from this formula here. We have calcium, we have hydrogen carbonate. So these 2 belongs to my calcium. Calcium is 2 plus. Okay, what is the charge of hydrogen carbonate? -1, very good. Okay, and then my question is how many electrons in hydrogen carbonate? So how many electrons are there? Okay, how many got A? B, C, D. Okay, only a few got C. The rest who didn't answer cannot find it. Okay, hydrogen, 1 by 1. Hydrogen, how many electrons? 1. Carbon? Carbon. Okay, why do I get it? Okay, 6. Okay, I have 3 oxygen, so each oxygen is 8. What else? I have a -1. -1 means I have extra 1 electron. Okay, hydrogen has 1 electron. Carbon has 6 electron because 6 proton. I have 3 oxygen, each oxygen 8, and then I have extra 1. Okay, what's the total? 32. Okay, so the answer is 32. Okay. All right, so isotopes, okay, again, isotopes, we know what is it and we discussed before. So isotopes, same atomic number. Again, can you tell me what does same atomic number means? Same proton number, and also, it also means what? Okay, same electron, and then what else? Same element, same identity. Okay, we are talking about same element. Okay, so same number of protons, same atomic number, same element, whichever you choose to use, also correct. Okay, but different mass number. What is mass number? Nucleon. Okay, as I mentioned before, different nucleon number, different neutron number, also acceptable. Also can be the answer. Okay, as long as you understand, they are same element, just that they have different number of neutron or different nucleon number. For example, carbon 12, carbon 13, carbon 14. Okay, all have 6 protons because they are the same element. Isotopes means same element. But with 12 mass number, it means that it has 6 neutron. 13 mass number, I have 7 neutron. 14 mass number, I have 8 neutron. Okay, so same identity, but different mass number or different neutron number. Okay, so where are isotopes being used? Okay, some isotopes are radioactive, some are non-radioactive. Okay, radioactive means it can break down and give radiation, break down, give radiation. Okay, so those that are radioactive, for example, I have sodium-24. I can use it to check for leaks. Okay, oil leak or gas. Okay, you know all the pipes, okay, gas pipes that it's normally underground. So if there's leakage, it's very easy for it to explode. Okay, so it's very important to check whether is there any leakage. Okay, next in medicine field, okay, we have iodine 131. Okay, in our neck here, we have something called a thyroid gland. Okay, so this thyroid gland, okay, is going to produce a substance. Okay, so we can use iodine to test. Okay, you eat an iodine pill and then they put it in this machine. Okay, and they're going to check whether is it functioning or not. Okay, if let's say I have friends whose thyroid gland is not functioning, so cannot have the hormone, have to eat medicine the whole life, okay, to substitute for the hormone. Okay, and lastly, okay, this one quite new, hydrogen-3, tritium. Okay, some of the watches, last time our watches, we paint colors, okay, so that they are glowing. Okay, but now some very expensive watches worth a car, okay, tens of thousands of ringgit, they actually use hydrogen-3. They put hydrogen-3 inside, so it will always continuously glow. Okay, but of course, it's a little bit radioactive because it's decaying inside. Okay, but it's very expensive. Okay, so hydrogen-3. Okay, write the isotopic symbols. Okay, so isotopic symbols means like, for example, bromine 81 and 35, like this. Okay, write the symbol of the element. Okay, try this. I've given you first one, 81, 35. Okay, calcium on top is 44, below is below 20. Okay, and then iron is, what is the symbol for iron? Fe, 58. 26, thank you. Palladium, not Pa. Not PO, Pd. Okay, palladium is Pd. You'll see number 46. Okay, so 110, 46. Okay, one question before I left you off for a short break. Okay, technetium-99 isotope is radioactive, can be found in lobster and seaweed, adjacent to nuclear fuel processing plant. Which statements are correct about an atom of technetium-99? Okay, take some time to calculate and let me know. 1, 2, and 3. which is correct. Talking about nuclear plant, recently, did you all watch the news that Japan is going to dispose, okay, their wastewater, okay, from the nuclear plant? Okay, and then it causes a controversy because, you know, Japan, they have all the raw fish, okay, raw sushi, raw sashimi, okay. So they're thinking if you dispose, okay, the wastewater in the ocean, is it safe to consume raw food? Okay, so finish calculating. Number 1, is it correct? Okay, let's see, technetium 99. Okay, let's break down the subatomic particle.
Yeah.
Proton, neutron, and electron. Okay, how many protons are there? PC.
43.
43 proton. Electron, also 43. Neutron, 56. Okay, 99 minus 43. Okay, then we can continue answering. It has 13 more neutrons than protons. Is it correct? Compare neutron and proton. Neutron is 13 more than proton. Correct? It has 43 protons. It has 99 nucleons. Correct. Okay. Only the first statement, a lot of students, okay, they didn't calculate. So a lot of students got this wrong. This is real exam question. Okay, it can be as easy as this, but what happened is student, they didn't calculate, so they couldn't figure out that it's 13 more neutrons than protons. Okay, so 1, 2, 3, correct. Okay, give you guys a 10 minutes break. It is 9:48. We will meet at 9:58. Oh, yeah.
They don't structure in the quiz.
What is that?
In the quiz.
Okay.
Only first.
Yeah, only until that's all. So no until that. Again, I'm very sorry. How to find out?
Yeah.
So,
So I have short name and one, let's say actually, like the same business. You can call me Valerie if it's easy.
because I'm afraid I cannot pronounce it properly.
Mm.
That Valerie.
That's okay.
Valerie.
Yeah.
The first name was?
So good. It's
Valerie is your family name.
it's my first name.
Or is your first name? So is it pronounced correctly? Valerie. How should I pronounce it?
No, that's okay because
No, I don't
actually
want to call you
it's pronounced Valerie.
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 You see the sound
Yeah,
the way on
what
the
kind
have in
of
Russian.
pronunciation?
It's on the international sound.
Oh,
So
okay.
I think Valerie is it's okay.
Valerie.
Yes.
I'm so sorry I pronounced it wrong. Thank you. Thanks. Okay. All right. Oh, thanks, Simon. Oh, okay. You have a
Yeah, sorry.
Yeah.
In the questions, can we depict like the volume in liters, or do we have to?
Okay. So this one, like, can I use blue?
Of course.
Okay. So this one, like I mentioned, it depends on your. For example, if you are, okay, yesterday I mentioned me personally, I always use 8.314. So in the data booklet, it's two values actually. Thank you. It's either 8.31 or 0.8. So if I use 8.314, my pressure will be kilopascal. My volume, decimeter cube, and decimeter cube is same as liter. Okay, so if you get decimeter cube or you get liter, you can just use it. And then your temperature is in. So if you get 821, then pressure in APM, the volume also decimeter cube equals to liter. Either one. So that means if you get centimeter cube, you need to convert to decimeter cube. Okay.
So when I write the answer, for example, in the in the task where you have to write the answer, can I write it in liters?
Can,
Yeah,
no problem. Because liter is same as decimeter cube. So even if you put liter, it's fine.
Yeah. Thank you.
Question.
Hold on, huh? FIS.
Yes, I'm a FIS2.
Or two choice not. I wanted to know your name. Or is it yes?
Yeah.
Which is
My name is Bex.
Oh, Shafkat.
Yeah.
Shafkat, huh?
Yeah.
Okay. Yes.
Teacher, atoms of same elements, compounds are formed by two or more atoms or molecules.
Atoms.
Atoms.
For example, let's say, compounds are, for example, if I have H2O, this is two atoms, three atoms.
Three atoms, two hydrogen, one.
Yes, correct. So I also call it compound. But of course, okay, if you say a lot of molecules, we will have, this is simple compound. We have a complicated compound. For example, we have NH4 and O3.
Yeah.
So this is
Molecules.
correct,
Yeah.
two molecules, but we also call it compound.
Can we call it simple compounds like carbon dioxide? It's also simple.
Yes, simple compound. So this is complex.
Okay, so thank you.
Okay. Class, again, I have 7 students who haven't filled in the name. Please do so. Jayan.
Simon say we are using a textbook. This slide is to represent the textbook.
Text? What text?
Textbook.
Uh-huh.
This all presentation is based on the textbook.
No, don't have a textbook. We only
don't.
have reference book. If you want to know the reference book, it's in the Moodle. I did show in the briefing. Did you check the briefing? Under necessary material is your briefing.
Oh,
I mentioned the textbook.
okay.
If you need the textbook.
Okay, thank you.
Ling Ning, you haven't signed. Hai Ruchi, what's for that? Joey, why I pass to you, you don't pass to them? Oh, and then, oh, okay. Sorry. Alhan, you were absent yesterday, right? You were absent yesterday, right? Okay. Jai, you haven't signed. Take Jai. Oh. Kim sign. Oh, you haven't signed. Okay. Xiao Hong not here. Chi Huang. He Chi Huang. He Chi Huang. Not here. Amos. Amos Siu. Also not here. Stephanie. Stephanie Chai. Oh, you were absent yesterday. Aidai. Ubaidilava Aidai. Not here. Wang Yilin. Oh, also haven't signed. Raouf is here, right? Alicia. Oh, were you here yesterday? Huh? Okay. Don't sign for yesterday, okay? All right. Okay. Can those of you who have not filled in your name, can you just admit and put up your hand? I have 7 students. Yes, just put up your hand. I just want to know. Okay, 1, 2, 3, 4, 5, 6. You also? Okay. 6 of you can form a group, but another one will have to join in here. Okay. If you don't have a title yet, at least put in your name, and group contract must be today. Okay. So I think Samad, you'll have a new member. Okay. I'm not sure who is going to join you. So please approach Samad, your group leader. All right.
Sign the contract.
Yes, very good. Okay. Be a fierce leader, Samad. Yes. Yes, because if you are slow, you are going to drag all your group members with you. Okay, your group members, they want to score good points. Okay, nobody want to score bad points. And if you do it slow, then everyone is going to be slow. All right, so let's continue with the next part of today's lecture. Okay, after this, I'm going to let you guys off. Okay, so it is a new instrument that we're going to learn. Okay, even though we are not going to do it. Okay, we're not going to use the instrument physically. Okay, but just to know what is the theory, okay, behind this instrument. It's called a mass spectrometer. Okay, so again, learning outcome. Okay. Okay, so this mass spectrometer utilizes a theory, okay, a technique which is mass to charge ratio. What is mass to charge ratio? Simply means mass over charge ratio. All right, for example, if I test a sodium, okay, and let's say this sodium has a positive 1 charge. Okay, can you tell me what is the mass of sodium? What is the mass of sodium? Okay, so 23, 22.99, 23. And what is the charge? 1. Okay, yes, +1. So it's called mass to charge. It's just like that. Okay, according to the mass over charge, I'm going to plot a graph. Okay, all right, so when I analyze, the analyzed particles must be in the form of ion. We will look into this later. Then we will check the molecular weight. Okay, so this weight represents the mass that I mentioned just now. It can be your atomic. If it is atom, then we say it is atomic mass. If it is molecule, then it is molecular mass. Okay, just as the usual mass that you learn. Okay, and perhaps to identify what is the chemical structure. Okay, so I'm going to draw on this directly. Okay, so there are 4 stages of mass spectrometer. Okay, the first is ionization. Okay, the name ionization itself. Okay, so what happened in this stage? I will simplify in this diagram itself. So what happened in this ionization stage is my sample will be ionized, will become ion. Okay, so for example, I have an atom X. This atom will become an ion. Okay, so what happened in ionization stage is, you notice here, the sample must first be vaporized. What does it mean by vaporized? Vapor. It becomes gas. Okay, so my sample must first be in gaseous state. Okay, then my gas sample goes inside the first stage, which is ionization stage. At this stage, I will have high energy electron. You know, last time you used to play, if you watch Squid Game, there is a game where you have a lot of glass beads in a circle, and then you're going to throw a glass bead, and then wait for one of the glass bead to go out from the circle. Okay, the same theory. So in ionization stage, I will have high energy electron. I bombard. Bombard means I keep on heating the atom until the stage whereby one of the electron is removed from my atom. Okay, so this is ionization. So this is the equation that represents ionization. I have a gaseous atom. 1 electron will be removed. I will form a gaseous cation. Okay? Okay, I have a question to test you. Will there be a negative, or it will always be a positive? Always positive, why? Only electrons can be removed. Because what I'm doing, remember, what happened in this stage is I'm going to bombard, okay? I'm going to heat the atom with high energy electron. When I heat it, 1 electron will be removed. So when electron is being removed, it will always be positively charged. So remember, only positively charged. Only positively charged. Okay, so second stage is called acceleration. Acceleration means I want to make it move fast. Okay, so in this acceleration, I will put in electric field. Okay, so this electric field is going to cause my ion, because ion is, sorry, yes? Oh, okay. You should have told me earlier. Thank you, thank you. Okay, thank you for seeing this. Okay, sorry for not sharing screen. Okay, thanks for reminding. So second stage is acceleration. Acceleration means I want it to move fast. Okay, so I will use an electric field. When my ion, okay, this ion that was being produced, okay, it passes by my second stage, which is this acceleration, it will move very fast. And why do I want it to move very fast? Because of the third stage, deflection. Because remember, if something moves very fast, when you push it, it can be deflected easily. If it moves very slow and steadily, you try to push it, I'm firmly here. Okay, so that's why I need to accelerate so that it can be deflected. So deflection is using magnetic field. Okay, and this deflection is according to what we say just now, mass over charge ratio. Okay, let me explain this further. Okay, for example, mass over charge that we learned just now. Let's say I have sodium positive. The mass over charge for this is, mass is 23 over 1, charge is 1. Okay, but there are sometimes accidents happen. I bombard high energy electron, remember? Sometimes not only one electron is removed. Sometimes there are 2 electrons being removed together. So when I remove 2 electrons together, I get sodium 2 positive. Can you tell me what is this mass over charge? 23 over 2. Which one is lighter or lower ratio? The second one, okay, lighter. Remember we learned just now, if it is lighter, what happened to the deflection? It will be deflected easily, okay? So this will be deflected more, and this will be deflected less. That is why deflection is according to mass over charge ratio. Even though 99% of the time, it will produce a positive 1 charge. But once in a blue moon, there is accident, they will produce 2 positive. So always double check, okay, what is the charge being produced? So mass over charge ratio. And then we have the last one, okay, stage number 4, the last stage is detection. Okay, so detection is whereby it's going to be detected as a graph. Okay, this graph, I believe you will be very familiar with. Okay, I have the percentage, and here I have the mass over charge ratio. For example, I detect sodium positive. Okay, each time a sodium positive hits, mass over charge is 23. So one time sodium positive hit, I produce a peak. Second time hit again, a higher peak. Third time hit again, higher peak. Hit. The more times, okay, I detect a sodium positive ion, the higher the peak, the higher the percentage. And we call this percentage abundance. Okay, and let's say, okay, there is once I hit, okay, I get to detect this sodium 2 positive. But because it's a very once in a blue moon kind of thing, okay, so maybe I detect it only once. Okay, so this will be under 12, 11.5. Okay, so a mass over charge 11.5 will produce a very small peak. And let's say I have an isotope, sodium 24 positive. Okay, so at mass over charge 24, hit 1 time, 2 times, 3 times. Okay, so a shorter peak. Okay, so the graph that's being produced, I call it a mass spectrum. Okay, and then anything, okay, that was being deflected away, that's not being detected, it will be removed through a vacuum pump. Okay, so this is all you need to know about mass spectrometer. Okay, I recap 4 stages, things that you need to know about mass spectrometer. Okay, 4 stages. First stage, ionization. Okay, what happens during ionization? High energy electron, I throw it. Okay, what's the purpose? To remove electron. 99% of the time, 1 electron is being removed. You need to know the equation. Okay, so 99% of the time, 1 electron removed, but sometimes accident happen, I might have 2 electrons removed. Second stage, acceleration. Accelerate means you press the pedal, go faster. Okay, so I will use electric field. So electric field will cause the ion, this ion that's being produced from the first stage, bring to the second acceleration, accelerated very fast. Okay, and what's the purpose of acceleration? Easily deflected. Okay, so that it can be deflected easily. And deflection is through magnetic field. I use mass over charge ratio. The lower the mass over charge ratio, the more I will be deflected. And the last stage is to detection. Detection according to how many times it hits the plate. Okay, if it was being hit many times, so more detection, higher percentage abundance. So the thing that's being produced is a mass spectrum. Okay, all right, let's go through the slides. Okay, so first stage, okay, recap. First stage, ionization. So what happened in ionization? It's being ionized. Ionized means I form ion. Okay, how do I form the ion? When I knock out, okay, one or more electrons. By what? I use high energy electron. Okay, I use high energy electron, I bombard, okay, into my atom so that it can remove the electron. And what's being produced? A positive ion, a cation. Okay, so this collision, okay, this bombardment, okay, this knocking off will cause my gaseous, it's a vaporized sample. Okay, will cause my gaseous sample to lose one of their electron and form a positive ion. So as I mentioned, this equation you must know. Okay, so it's a gaseous sample. It will form a positive ion, also in gaseous state, giving off one electron. Okay, so what happened here? Okay, just to show, bombard. Bombard means hit. Okay, hit with high energy electron and knock off one of the electron. Okay, so just like this. Okay, I hit. There was originally an electron here. I hit it so the electron is removed. Okay, next stage, acceleration. Acceleration is by electric field. Okay, so that they move very fast. Okay, so when I have electric field, I cause them, because they are ion, okay, I cause them to move very fast. And then I reach the deflection stage. Deflection using mass to charge ratio, whereby the lighter, the more they are deflected. Okay. Okay, and then deflection depends on the mass and the charge. Okay, the lighter my mass, deflected more. Okay, if the charge is 2, the higher the charge, okay, of course, the more they are deflected. As we see just now, okay, 23 divided by 2. 23 divided by 3, even lighter. Okay, the higher the charge, the more they are deflected. So when I combine these two factors together, I call it mass over charge ratio. Okay, so for example, okay, when I have these streams here, I have stream A, stream C, and stream B. Okay, stream A deflected the most. Okay, so I can say that it is the lightest. Okay, stream C deflected the least. Okay, so I can say it's the heaviest. So which one will be detected in the detector? B. Okay, so this one I can adjust. So for now, I'm going to detect stream B. So the other A and C will be deflected. Then only B will be hitting the plate. Then I count, okay, B. This is the percentage. And then I adjust my machine. I will detect stream A. So B and C will be deflected. So I count, okay, A is high. And then I adjust again. I want to detect stream C. So A and B will be deflected. Okay, so stream C, okay, maybe only this high. All right, so each time one stream, okay, one ion will be detected. Then I repeat many times, I will produce many peaks. Okay, and then lastly, the last stage, detection. Okay, so the detector counts how many times the ion Heat. Impact means heat. Okay, how many times the ion hit? And then from this, I can measure what is the percentage abundance. How high, okay? How much is that naturally? Okay, and then the signal can be amplified. Amplified means the signal will get bigger. Okay, and lastly, I produce a mass spectrum. Okay, so this is the mass spectrum. Only one stream is detected at one time. I need to adjust if I want to detect the other streams. Okay, so only stream B, okay, only ion B, as we discussed just now, move through the detector. Okay, so other ions that were being deflected, they will be neutralized and then pumped out from a vacuum pump. All right, so this is just a summary, okay, of what is going to be produced. All right, I give you guys 1 minute, okay, tidy up your thoughts, okay, any notes that you're missing, you can let me know. I can go back to the previous one, okay, so 1 minute. All right, so mass spectrometer, you are not going to use it. You just need to know how it functions. So the 4 stages, what roughly happen in each of the stage. For example, the first stage, okay, you need high energy electrons. Second stage, we use electric field. Third stage, we use magnetic field. Okay, those points that I mentioned just now. Okay, those are the things that are important for your exam. Okay. I'll start giving hint on and off, okay, because I just finished setting the final exam paper. Okay, so if you want to know more, you have to pay attention. Okay, when I say these are the things that will be tested in exam, then you just put a note on your own. Okay, any question, anything you want to ask, clarify? Okay, all right. So what is going to be produced is a spectrum. Spectrum is the graph. Okay, so this graph will show the percentage or the relative abundance, or sometimes we call it intensity. How intense is the peak? Okay, intensity. Okay, meanwhile, here is the mass over charge ratio. All right. Okay, so what can you get from this mass spectrum? Okay, just by looking at this, what is the information that you can tell me? Throw me some ideas. What can you read from this graph? Okay, 35 is a chlorine. So I say that chlorine 35, highest percentage because 75%. And then, okay, chlorine 37, you get slightly lower percentage is 25%. Okay, how many isotopes of chlorine are there? Okay, 2 isotopes. So we know that one is chlorine 35. Another is chlorine 37. Okay, all right, so what can we obtain from a mass spectrum, the one that you mentioned just now? How many isotopes? If you have 2 peaks, you will have 2 isotopes. Okay, and then next, what is the mass? You mentioned just now, chlorine 35, chlorine 37. Okay, because you know the mass, so you know the identity. One of it is chlorine 35, one of it is chlorine 37. Okay, and lastly, what is the abundance? What is the percentage of the isotope? 75 and 25. Okay, so these are the things that you can get from a mass spectrum. Okay, there are a few questions after this. Okay, so I think those questions are testing on calculating, okay, atomic masses, which we did in chapter 1 also. Okay, so to calculate relative atomic mass from a mass spectrum, I have mass over charge, I have percentage. Okay, so I hope you still remember. Let's say just now you have chlorine 35, chlorine 37. 75%, 25%. Okay, how do you calculate relative atomic mass? Use the mass multiply by percentage. 35 multiply 75, okay? Plus everything divided by total percentage, 100. Okay? All right, so the examples, I think we will discuss next class. Okay, you can try to do, since those are all relative atomic masses. 1, 2, 3, 4, 5. Okay, 5 questions. Okay, I wish to remind you of something. Okay, that's why I wish to stop here. I have posted an announcement yesterday evening or night evening. Okay, regarding the quiz. I don't want anyone to say that they don't know. Okay, so the quiz will be next Tuesday, 5 to 5:30. Okay, 30 minutes. Please come early because we have 300 students. I cannot let you come in sharp 5 p.m. Okay, so come early, then we will let you in early because we need to check. Did you bring anything else? Okay, like electronic gadgets, or you cannot bring in. Okay, venue of the exam of the quiz is at LY3. LY3 is a large building near all your hostels, LY blocks. Okay, if you are not sure where is it, I advise you to try to look for it earlier. Okay, so I'll look at this seating arrangement later. 10 MCQ questions. MCQ means multiple choice. And 1 structured. Okay, 5 marks. So chapter 1, as I keep on saying, chapter 1, moles and equations until yesterday, gaseous state, the gas laws. Okay, 1, bring your own calculator. No handphones, cannot. Okay, bring calculator. If you don't have calculator, then I don't know, you survive on your own. I've reminded. Okay, and very dark pencil, because you will need to shade your answers for MCQ. Make sure you shade properly and dark enough. If not, it cannot be detected by the system. Okay, I can advise you, if you want to use mechanical pencil, the one that's very dark, yes, go ahead. Because the normal pencil that you need to sharpen normally is not very dark. Okay, and other stationaries, for example, you need ruler, you need pen, okay, please bring it. Your structured question, please use pen to answer. Okay, so answer everything in the question paper, and then the MCQ sheet is for you to shade your answer. There's also a table provided just to double confirm in case. You can write the answer in the table. Question 1A, question 2B, question 3E. Okay, data booklet will be provided. It will not be exactly the same as what you have now. Okay, but periodic table definitely there. Important values definitely there. I have checked through, okay, the formulas, they are not useful. Okay, so the formula sheets are not useful for the quiz. Okay, mobile phones are not allowed. So you either leave it in your room or you put it inside your bag before you come into the exam hall. Okay, so your lecturers, the invigilators have the right to check your pockets for handphones. So please don't bring handphones. Electronic gadgets are like vape. No. Okay, smart watches, no. All right. Okay, so okay. So this is the seating map. Okay, so when you go in, here are the main entrance down here. These are the main entrance. Okay, you will go in from the side here. So FIS, it will start, okay, from the right to the left. So FIS1 will be seated these 2 rows. Please sit accordingly, according to the rows. Okay, if you sit at the wrong place, your quiz is not marked. It's not my fault. I have mentioned sit at the correct place. Okay, so free sitting here. Don't need to sit according to what number. Okay, so 2 rows for FIS1, 2 rows for FIS2. Okay, so you just calculate. I will also label, but behind that. All right, okay, any question?
We don't need to see anything whiteboard.
No, you don't need to see anything from the whiteboard. Yes. Yes, leave your bag outside before you come in. Okay, anything else? No need to bring laptop.
No, that's the booklet.
Oh, data booklet, no need. Data booklet not allowed to bring in. Okay, you can only use the one provided. Okay, anything else? No? Okay, if no question, then that's all for today. Okay, so thank you, class. Have a nice day.